Everyone, welcome into class today. Let me first of all introduce myself. My name is Mr. Steve Griffin, and I will be your math teacher. This is going to be pre-calculus class, so welcome to pre-calculus. Let me just tell you a little bit about my background. That way, maybe it'll help you to understand a little bit more about who I am and where I'm coming from. You may be wondering what DRG math stands for. So let me kind of explain that real quick. I do not have my doctorate. I'm not a doctor of education, although I'm getting there. I'm close. So maybe someday that'll stand for doctor. But I'm working on my doctorate right now. But don't call me doctor yet, okay? Because I haven't quite made it. So if I do, I'll let you know. But for right now, Mr. G or Mr. Steve. Most of my students have always called me Mr. Steve, and I'm okay with that. Or Mr. G, that's fine too. Mr. Griffin, anything. But DR, what does it stand for? Well, I was a missionary in the Dominican Republic for 10 years, and I taught at a Christian school there, taught math, and did some other things there in our ministry, worked in the church, and so I just love the Dominican Republic. If you look at the logo, there's a plus sign in the middle of the logo, but if you look at the Dominican flag, you'll see the colors and you'll see that plus sign in the middle of the Dominican flag. So that's kind of neat. And, with math and the plus sign, I just thought it was really cool. So that's a little bit about DRG. Hopefully someday it'll stand for doctor, but right now it stands for Dominican Republic. And my heart is there in the Dominican. I love the Dominican Republic, but God's called us back to the United States, and but still in education and working with kids. So I have been teaching virtually and through hybrid means for the last few years. All in all, I've been teaching for about 17 years as I'm making this video. So, however old this video is, you can add those years to 17. So, what I'm saying is, I'm older than most of you. I've been teaching longer than most of you have been alive. And so, I've been doing this for a while, and hopefully, we'll be able to learn from each other. You'll be able to learn from me in this class. So hopefully you have a copy of your textbook. The textbook is Pre-Calculus with Trigonometry and Analytical Geometry, and that is an Abeka book. This should be what the front of your book looks like. If it's not, then you probably need to get a new book and make sure that you're in the same book with us, or else you're going to be pretty confused pretty quickly. So if you don't have a copy of that book, head on over to Abeka Books website and make sure that you get a copy of that book, because it is very important that you have that book, or else you're gonna get confused and you're not going to be able to keep up. So grab a copy of the book, and we're going to start today on page number 2. So chapter 1 starts on page number 2. So you can go ahead and look at that. I'll go ahead and put that up here on the screen. We're going to start by talking about some basic concepts of pre-calculus. Now, in order to get to calculus, or even to get to pre-calculus, you have to have some basic concepts down. And I'm trusting that you've taken algebra and you've taken geometry, and if you've taken even algebra 2, those would be what we call prerequisite courses here. But before we really jump into the book, and in order to kind of understand where we're headed, we need to understand some basic concepts. So before we go any further, I think we should do this review. Some of you will look at this review and say, oh boy, I already know how to do this, and this is easy. And that's great. Hopefully it is easy for you, and hopefully it is just a review for you. Well, if you look down there, we're going to start by reviewing our geometry. God's creation is full of geometric shapes, and it really is. One shape that they're showing here is the angle, the relationship between an H2O molecule. So maybe you have learned that in science class. It has a 104.5 degree angle, and all of them have the same angle. One thing that God has created in this universe, in this world that we live in, is He's created things that are aesthetically pleasing to our eyes, things that always are the same. They never change. They always look the same. They always react the same. And molecules are one of those things, and they hold their shape, they hold their pattern, and that's what really holds the universe together. If they didn't hold their shape, again, going back to science class, you've probably learned that if they didn't hold their shape, then they would become unstable, and that's when you have problems, explosions, things like that. Splitting an atom is how they made a very powerful bomb, and they can make nuclear fission, they can make energy, and different things like that. Well, what that's doing is that's separating the bond that holds that atom together. It's separating that angle there. So geometry is tied into all these different things. If you take a look here at this water molecule, it kind of looks like Mickey Mouse, kind of laying down on the side, but it kind of looks like Mickey Mouse. And as I kind of looked at that and I thought about that, it's really quite amazing how in Disney's movies and different things, you had to be very careful about the geometrical lines that you draw in the characters, because these lines end up defining the character. And if any of the lines are off just a little bit, if the triangle's not perfect, if the circle's not perfect, if there's any problems anywhere, then the character doesn't look quite right. And Disney has spent, millions of dollars over the years trying to get these characters to look just right. Another interesting thing, and maybe when we get to it, we'll watch this movie, but I've seen, it's not really a movie, it's more like a documentary, but I've seen a documentary on the creators of Toy Story and some of the things that they did using trigonometry, geometry, and calculus while they were making Toy Story. And one of the ways that they got the people to be so, the characters to be so spot on and to look so good is they used different formulas, and they used different things, different principles from math. And so maybe we'll watch, once we get into that lesson a little bit later, maybe we'll watch that documentary. But it's really neat stuff. All right, let's go through this. We're gonna look down here on page 2. We're gonna look at Table A. And what is Table A? Well, Table A is talking about the different types of angles. So you have the acute angle, and that is any angle that is less than 90 degrees. You have the right angle, and that's any angle that equals 90 degrees. Then you have the obtuse angle, and that's any angle that is greater than 90 but less than 180. Okay, hopefully you know what these signs mean. Okay, that's the greater than sign, and that's the less than sign. So greater than 90, less than 180. Then you have a straight angle, and the straight angle equals 180 degrees. Again, this should be review from geometry class. I'm not teaching you anything right here. We're just reviewing things that you already know. If you don't know these things, then you probably need to go back, find a video on them, teach yourself the different types of angles, because these are important angles in precalculus and in trigonometry that we'll be studying here in this book. The last one is the reflex angle, and the reflex angle is any angle between 180 and 360. Then we talk about the classifications of triangles. We have the scalene triangle. The scalene triangle has no equal sides. Every side is different. So you have one side of, let me show it to you over here. So you have something that looks like this. Maybe you have one of your sides of your triangle, maybe something like this. And so they all have different sizes. So maybe the size of this one is 5 inches, and the size of this one is 7 inches, and the size of this one is 8 inches. And so every side is different. That's what we call a scalene triangle. And you're still following along in your book, but I'll keep it here on this page so I can show you the different types of triangles. The second one that we'll talk about is the isosceles triangle. All right, so what does the isosceles look like? Isosceles is interesting, and we're actually going to study it just a little bit. You probably studied it quite extensively in geometry class. But the scalene triangle has, or the isosceles, excuse me, has two sides that are equal. So maybe this is 7, and this is 7, and this is 4, okay? And so we learned that in geometry, we learned that they have relationships, and this angle down here equals this angle down here. So angles opposite equal sides in a triangle are equal. So those two angles down here are equal to each other. And so that's the isosceles triangle. Hopefully as I'm going through these, you're going, oh yeah, I remember that from geometry. If not, go back and review some of these things on your own. The next one is the equilateral triangle, and that's the one that the whole thing matches. And so, in other words, all the sides are the same. So in this one, maybe this side is 4, this side is 4, and this side is 4. And that's an equilateral. And then all of these angles would have to be equal as well, because remember, any angle opposite an equal side is equal, so all of these are going to be equal. In an equilateral, they're all 60 degrees. You remember that, right? Because, remember, a triangle has to add up to what? Has to add up to 180 degrees. So you have all three sides of that equaling 180 degrees. So if they're all equal, then you would just divide 180 by 3, and you would come out with 60 degrees each. They have to be 60 if it's an equilateral triangle. And then we classify them by their angles as well. We have acute triangles. That's where you have 3 acute angles. We have right triangles, and that's where you have 1 right angle. That's the one that we're going to focus on the most, okay? So that's the one that looks like this. So you have a right angle right here, okay? What does that mean? That means it's a 90-degree angle. And that's very important in trigonometry, because almost all trigonometry is the study of triangles, but really specifically it's the study of right triangles. So we're going to basically in trigonometry, we're going to be studying triangles with that right angle right there. So we're going to be very familiar with that by the end of this year. Then we also have the obtuse, and that's when you have a angle that is greater than 90. And then you have the equiangular, which is also equilateral, and that would be the 60 degree. That's the one we just talked about up here. Okay. All right, on the next page, go over to page number 3. Let me go ahead. I'll swap over to that real quick. All right, on page 3, again, this is review. It should be review. We talk about the Pythagorean theorem. What's the Pythagorean theorem? Well, that's a squared plus b squared equals c squared. The problem is in trigonometry, we're going to switch that up, and pretty soon you're going to get you're going to be using X's, Y's, and R's. And I won't, throw your mind too much for a loop yet, but the hypotenuse in trigonometry is the R. So we'll be switching the C for the R, and then the adjacent side and the opposite side, those switch to X and Y, and that's all based on the Cartesian plane. So when we get there, it won't be that big of a deal. We're just switching out the letters. So let's go ahead and go back over here, and let's work one of these problems. So let's take a squared plus b squared equals c squared. Now let's kind of manipulate this real quick. What do I mean by manipulate? I mean just kind of switch it around. All right, so what does that mean? Well, let's switch this around, and let's put c squared out front, because normally the x it comes first. It's on the left side. That's what you like to see. So this is what we're looking for. C squared equals a squared plus b squared. We want to get c by itself. Let's say we're looking for c. We're looking for the hypotenuse, right? So what we want to do is we want to square root both sides. Now notice we haven't changed anything yet. We haven't put any numbers in yet. We haven't put any input in. We're just manipulating the raw formula right here. So when we do that, what happens here is we can cancel the square root sign with the squared, because they're the opposite of each other and they just cancel out. So what we end up with is c equals the square root of a squared plus b squared. This is, and actually it's plus minus here. This is actually the Pythagorean theorem that we're going to be using. You need to know that right there. That's a very important formula, because we don't want to go through this right here every single time. It takes too long. It's just not user-friendly. this is like doing most of the problem right. We can plug this right into our calculator right here, and this is probably the easiest way to do that formula. You can see a couple of examples in the book. Let's do one of those. The first one says, to find the length of the hypotenuse of the right triangle. So let's say we have a right triangle, and the sides are A is 3.0. Try that 3 again. 3.0, there we go. And then B is 1.0. And that's not to scale. That doesn't look right, but we are just drawing a rough drawing. You'll see me drawing lots of rough drawings this year, okay? I don't spend a lot of time making my drawings perfect. I just kind of get them down on the paper so that I can kind of see what I'm doing. It helps me as I'm solving things. If you didn't do that in geometry, you really need to get into the habit of writing down a picture, drawing the triangle, getting it down on a piece of paper. That will really help you to solve these problems a lot easier. All right, so this is our C side. This is our X. This is what we're looking for. So how do we find that? Well, if you look over here, we're looking for the C. So we're just going to substitute C in for that C. All right, so C, that's what we're looking for, so it stays, equals positive, negative. And then we have, and a lot of times we didn't do this positive, negative in geometry, did we? And there's a reason we didn't do it in geometry. You don't need it in geometry because you can only have positive sides in geometry. You can't have negative in geometry. In other words, your triangle can't be negative 6 feet long. Okay? It can only be positive 6 feet long. So we didn't use this plus minus sign in geometry. But here in pre-calculus, in trigonometry, we are going to use the plus minus sign because, believe it or not, you can have negative sides in pre-calculus, in trigonometry. It's a thing. Okay, so we're going to need that. It's very important to us. So keep that plus minus sign there. All right, and then we're just going to plug in. It said that A was 3, and we don't need the 0.0. That doesn't, it doesn't help us any here. So we're going to have 3 squared plus 1 squared. And then we would just solve that, and you can plug into your calculator at that point. I'll do it longhand here so you can see it. Be plus minus 3 squared is 9 plus 1 squared is 1. So 9 plus 1, or plus minus the square root of 10. Now, plus minus the square root of 10 is a good answer. There's nothing wrong with that answer. In fact, I like that answer. So if you leave it as the square root of 10, then that's a more accurate answer than it would be if you solve it out. So you could also solve it out by going to your calculator if you like, and go up here and you hit your square root sign, and then 10 equals there we go, 3.162. So 3.16, if we're rounding to the nearest tenth, we get 3.2. So that equals 3.2. So our other side for this, C equals 3.2. Okay? All right, the next example there in your book is just almost exactly the same. I'm not going to take the time to do it, but what I will do is I will show you that they do change the formula a little bit. So now we have the hypotenuse. We're missing a side. We're missing the A side. So now it's C squared equals A squared plus B squared. But the thing is, we're missing the A. The A is what we're looking for. So what we want to do is we can plug into that. For example, if you're looking at the book, C is 10. So 10 squared equals A squared. That's what we don't have. That's the missing side. Plus B squared, and B is 5 in this example. Okay. So what we need to do is we need to take this 5 over to the other side to get A by itself. That's the goal here. So we're going to subtract 5 squared from both sides. So we're going to end up with 10 squared minus 5 squared equals A squared. Now what we would want to do, I'll change the color here, we would want to square root both sides of that, and that's going to cancel, and we're going to get the square root of 10 squared minus 5 squared equals A. Now you can finish it from there, okay? and that will give you your answer. One more thing that I want to show you is, and this would be plus minus, by the way. All right. One more thing that I want to show you is in your book, you see after they solve this, like let's go back up to this one here where we got the plus minus square root of 10 equaled, and actually that equals plus minus 3.2. But if you look in your book where the equal sign is, they don't use an equal sign, okay? They use something that looks like, I think it looks like bacon, all right? So I call it bacon. So you might hear me call it bacon. So that looks like two pieces of bacon right there. What is going on? Why didn't they use an equal sign? Why did they use bacon right there? Well, the reason they use that sign is because this means approximately equal to, or almost equal to. Why? Because remember when we had our calculator, remember what our calculator said? 3.162277. We don't need to write that whole thing. When we round off, okay, to the nearest tenth, it means it's not exactly equal to that. It's approximately equal to that. So that's where we would use the bacon right there, when it's approximately equal to. So that's going to be something that's useful all the way through the book. All right. Well, that is all that I have for you in this lesson. Hopefully you learned something today. Make sure you go and try some of those practice problems right there, okay? You're not going to get good at this if you're not practicing. So page 3 and page 4 has some practice problems that you can work on. And some of you are thinking, man, trigonometry is easy. I love it. All right, so far so good, right? That was a review. So hopefully you did find some things there that you knew how to do. Okay, we'll see you later. Have a good one. Bye-bye.